In this lecture, we will obtain an expression for numerical aperture. You just recall from the last class that what is numerical aperture and what is angle of acceptance. Now you see there is a diagram of optical fiber and light is allowed to fall on the optical fiber in the launching zone. If we take the refractive indices of launching zone, core and cladding as mu0, mu1 and mu2 respectively, then what we can say that core is denser to the cladding and the medium of launch is rarer to both of them. Now if the light is allowed to fall over the optical fiber, the whole amount of light will not pass through it. Only the ray of light which is suffering the total internal reflection will pass through it. So we'll have to know other ray of light which is not suffering the total internal reflection at the core cladding interface, that will be lost through the cladding. So here if we take that theta I is the angle of incidence at the launching zone of the of the optical fiber, and if theta r is the angle of refraction, then the ray of light AB is falling at point B on the core cladding interface. If we drop the perpendicular from point B to the axis, that is fiber axis, then we will get a normal BC. Now if angle ABC is, which is the incident angle of incidence, is greater than the critical angle to be determined at the core cladding interface, then the ray will be reflected back in the core medium. This is called as total internal reflection. So that we will try to find out later on, but one thing is to be noted here, that the light which is falling at the angle of acceptance, only that will suffer the total internal reflection, and other light ray which is falling at any other angle rather than the angle of acceptance, that will be lost at the core cladding interface. So for propagation of the light from receiver transmission end to the receiver end, it is very much essential that it should suffer the total internal reflection and pass through the core medium without any distortion, without any attenuation to the receiver end. If we apply the Snell's law, which is the second law of refraction at point A, which is the point at which the light is allowed to fall over the optical fiber, then what we know that sine of angle of incidence to the sine of angle of refraction is equal to the refractive indices of two mediums. So here also we will write sine theta I by sine theta r is equal to mu1 by mu0. Let us call this as equation number 1. Now as I told you earlier that if we drop the perpendicular from point B on the fiber axis, then a triangle will be formed ABC. So from that right angle triangle ABC, we can write sine theta r. Theta r is the angle of refraction. So sine theta r, that can be written as sine 90 minus phi. Phi is the angle of incidence at core cladding interface, and theta r is the angle of refraction, and you know that angle BCA is the 90 degree. So because of that we can write sine theta r is equal to sine 90 minus phi. Now sine 90 minus phi is equal to cos phi. So let us call this as equation number 2. Using equation 2, in equation 1, what we conclude? We conclude that sine theta I by cos phi because from equation number 2 we want to know that sin theta r can be replaced by cos phi. So sin theta I by cos phi is equal to mu 1 by mu naught, because mu 1 is the refractive index of the core, mu naught is the refractive index of the medium of launch. So from that we can find sin theta I is equal to mu 1 by mu naught into cos phi. Let us call this as equation number 3. Now if the ray of light AB is falling at point B, that is core cladding interface, such that it is having the angle of incidence greater than the critical angle, then it will be totally internally reflected. It is possible only when the angle of incidence in the medium of launch, or you can say that at optical fiber and the medium of launch interface is equal to the acceptance angle. That is, if theta I, the angle of incidence, is equal to the angle of acceptance, then we will be able to replace equation 3. Why? Because phi equal to phi c. Phi c is critical angle. We have taken critical angle is the angle at which the light ray to the interface. So if phi to phi c, this is possible only when angle of refraction will be 90 degree. That means when phi r will be equal to 90 degree, then phi will be equal to phi c, where phi is the angle of incidence at core cladding interface. If we suppose that phi r is the angle of refraction in the cladding medium, so if phi r equal to 90 degree, then this is possible only when phi equal to phi c. At that time theta I equal to theta a. So from equation number 3 we can write sin theta a is equal to mu 1 by mu naught into cos phi c. Now let us apply the Snell's law at point B, that is core cladding interface. What we will get from that? Sin phi c by sin 90, because angle of refraction in the cladding medium is 90 degree, is equal to mu 2 by mu 1, where mu 2 is the refractive index of the cladding. So from that we can write sin phi c is equal to mu 2 by mu 1, because sin 90 is 1. So if the value of sin 90 is 1, then sin phi c will be equal to mu 2 by mu 1. From that we can find out the value of cos phi c. Why we want to find out the value of cos phi c? Because we require this value of cos phi c in equation number 4. So that is why we know the formula cos theta equal to under root 1 minus sin square theta. So here also we will use cos phi c is equal to 1 minus sin square phi c. From that, if we put the value of sin phi c, then that will be equal to root over 1 minus mu 2 square by mu 1 square. From that, if you take the LCM, if you solve it, you will get mu 1 square minus mu 2 square by mu 1. Let us call this as equation number 5. Now recall the equation number 4. It was sin theta a is equal to mu 1 by mu naught into cos phi c. If we use the value of cos phi c obtained in equation number 5 to equation number 4, it will become sin theta a is equal to mu 1 by mu naught into under root mu 1 square minus mu 2 square by mu 1. Here mu 1 and mu 1 will cancel to each other, and because of that we will get sin theta a is equal to under root mu 1 square minus mu 2 square by mu naught. Now we have defined this sin theta a as numerical aperture. You just recall the definition of numerical aperture. It is defined as the sine of angle of acceptance. So here sine of angle of acceptance comes out to be root over mu 1 square minus mu 2 square by mu naught. So this will be equal to the numerical aperture. So from that we can calculate, we will conclude that numerical aperture is equal to root over mu 1 square minus mu 2 square by mu naught. From that we will be able to find out the value of numerical aperture. Now we can also find out the value of acceptance angle. Acceptance angle was what? The angle of incidence for which the light falling on the optical fiber got totally internally reflected multiple times and reached to the receiver end without any distortion, without any attenuation. So that angle we will have to find out, and that angle will be equal to sine inverse of under root mu 1 square minus mu 2 square by mu naught. So equation number 6 and 7 are very important relations which gives us respectively the numerical aperture as well as the angle of acceptance. Advantages of optical fiber communication. What are the advantages of transferring the data or signal from one place to the other place with the help of optical fiber? We want to know. So one very important advantage of communication with optical fiber is that the optical fiber can have the length of 250 kilometers, and because of that it can be there is no use of jointers, and due to which the losses can be minimized, whereas in the coaxial cables what we know that their length is maximum 5 or 6 kilometers. So after that, if you want to transmit the data from one place to the other place, and if the distance is 250 kilometers, then we require several coaxial cables, and at each and every jointers are due to which the data got lost. So this is minimized or very less in the case of optical fiber communication. Rather than that, it is free from corrosion. It is not having any effect of water or chemical. So because of its non-corrosiveness property, it can be used under seawater for communication. One very important advantage of using optical fiber is that it is having enormous bandwidth. The bandwidth of the optical fiber is 10 to the power 5 gigahertz, due to which there are plenty of channels available, so large amount of data with very high speed can be transmitted from one place to the other place. This is optical fiber is used in the we can say that in the computers. This optical fiber has got the use in the field of medical science. In the medical science, to see the internal part of our organ, it is used what we call as endoscopy. There the optical fiber is used. It is made of glass, so it is already electrically isolated. Due to that, because glass is what? Glass is insulator. So isolation is there. There is no danger of spark hazards in the electrical hazardous environment. The cost of optical fibers are less in comparison to the coaxial cables. So the communication becomes less costly with the help of optical fiber. There is no cross talking. There is no interference, because it is protected well from the interference of the sound or interference of the light. So that is why it is used in the cable television. Because of its less weight and small size, it is highly suited for aeronautical and space applications, because weight is less as well as size is small. The signal is well protected and privacy is maintained in the optical communication. It is highly flexible, because glass fibers are used, so it is highly flexible. There is no rigidness in there. It is also protected from any voltage or any type of electrical problem. Applications of optical fiber. This optical fiber is used in communication. Because of availability of large amount of channels due to high bandwidth, a large amount of data can be transferred from one place to the other place with the help of optical fiber in comparison to the radio waves and microwaves. In high privacy areas, that means in the defensive services, optical fiber system is used because it can preserve the data with privacy. This optical fiber is also suitable for transmission of digital data generated by computers. In hazardous areas like mines, oil rings, wells, the communication is done with the help of optical fibers because they are made of insulators, and if there is any case of fire, then it will retain for a longer time. Optical fiber system is used for signaling processes. Fiber optic sensors are used to measure temperature, pressure, liquid levels, rotary and linear positions at several places. It is also used for viewing the inner part of an organ, so in the endoscopy it is widely used. Optical fiber is also used in military services for communications, commanding and control links on ships, aircraft. It is also used in cable television, in satellite signaling, in satellites, in aeronautical field. It is highly used.